The Tiamat Sulcus calibration priority. The Tiamat Sulcus region on Ganymede is the primary target for the mission's first subsurface radar scan because its tectonic grooves suggest the shortest path to liquid water. As of June 2026, the European Space Agency has locked in the instrument calibration sequences for this September's Earth flyby, specifically to test the RIME antenna against known terrestrial ice sheets. This is a critical engineering hurdle because Ganymede's unique magnetic field creates a plasma environment that could mask the very cryovolcanic signals JUICE is designed to find. Detecting a 9 MHz return signal from deep within the ice requires a signal-to-noise ratio that the team is currently refining. These grooved terrains represent the best chance to observe active brine injection into the crust, but the radar only provides half the data required to prove Ganymede is geologically alive. Radar constraints and subsurface resolution. The RIME instrument faces a brutal physical constraint. It must penetrate up to 9 kilometers of solid ice while maintaining a vertical resolution of about 30 meters. This is not a simple camera. It is a long wavelength sounder that effectively ignores surface dust to see the dielectric contrast of water-filled pockets. If Ganymede's cryovolcanoes are active, RIME will detect hyperbolic reflections caused by subsurface reservoirs or dikes. The challenge is that at 9 MHz, the antenna is susceptible to Jovian radio bursts, which can overwhelm the receiver. Engineers are currently simulating data cleansing algorithms to ensure that the radar can distinguish between actual geological structures and electromagnetic interference from Jupiter's magnetosphere. This radar depth mapping must then be correlated with thermal data to confirm the presence of heat, thermal signatures, and infrared windows. The MAJIS spectrometer is the second half of the detection strategy, specifically tuned to the 3 to 5 micron infrared window, where internal heat escapes to the surface. While the surface of Ganymede sits at a baseline of roughly 110 Kelvin, an active plume or a recently erupted flow would manifest as a thermal anomaly several degrees higher than its surroundings. The June 2026 target list update prioritizes the dark, non-ice material found in the Nicholson Regio, where salt deposits may act as a chemical marker for recent activity. MAJIS doesn't just look for heat. It maps the distribution of magnesium sulfates and carbonates that are only stable if they were recently brought up from a subsurface ocean. If the radar sees a void and the infrared sees a hotspot, the mission proves Ganymede has an active energy budget. The real implication. The search for cryovolcanism on Ganymede is less about finding spectacular eruptions and more about defining the moon's internal energy flux and tidal heating constraints. By correlating the subsurface radar depth profiles with the thermal anomalies identified by the MAJIS spectrometer, we transition from speculative geology to a quantified model of the Jovian system's energy distribution. For mission operators and planetary strategists, this data determines whether Ganymede is a frozen relic or a dynamic world with a self-sustaining internal engine. This shift in understanding directly impacts the payload requirements for the next generation of landers, which must be designed to withstand the brine chemistry we identify now. If JUICE confirms active venting at Tiamat Sulcus, it proves that tidal flexing from Jupiter provides enough work to keep subsurface oceans liquid, despite the moon's distance from the sun. Watch the September 2026 Earth flyby data release for the final RIME calibration benchmarks. Subscribe for more.